Okay, let's dive right into this. We all use apps and gadgets that promise to find us the best of something, right? But have you ever really stopped to think about how they can guarantee it? How can a computer program be so sure that I didn't miss some secret, amazing shortcut? Well, that's the magic behind the A-star algorithm, and it all boils down to one kind of counterintuitive idea. I mean, think about your GPS. When you punch in a destination, it doesn't just give you a decent route. It claims to give you the fastest one, the absolute best. To pull that off, it can't just wander around aimlessly. It needs a solid strategy, a way to make really smart choices at every turn. So the whole secret is this. It uses an educated guess to figure out which way to go next. Now, in the world of computer science, we call this a heuristic. It's basically just an estimate of how much further you have to go. But, and this is the key, the kind of guess you make changes everything. Are you a pessimist who overestimates how hard it's going to be, or an optimist who underestimates it? That choice makes all the difference. To really get a feel for this, let's just forget about code for a minute. We're going to go on a little shopping trip. Trust me, this little story is the perfect way to understand how A-star really works. Okay, so imagine two people. They're both hunting for the exact same laptop, and the actual price tag on it is $1,500. Our first person, the overestimator, walks into the store thinking this thing is going to cost me at least $2,000. So when they see the real price, they think, wow, what a steal, and they buy it right there on the spot. But then you have our second person, the underestimator. They walk in expecting to pay only $1,000. When they see the $1,500 price tag, they pause and think, that's more than I thought. Maybe I should check the store next door. See the difference? The underestimator keeps their options open. That careful, optimistic shopper is a perfect model for how the A-star algorithm thinks. It uses something called an admissible heuristic. Now, that sounds super technical, but all it means is that its guess, what we call H of n, is always optimistic. It's guaranteed to be less than or equal to the real true cost. It is a professional underestimator. And that optimism, well, that's its superpower. Okay, so let's get back to the actual algorithm. We're going to run a little simulation. First up, we'll try it with the logic of our hasty, overestimating shopper and see exactly what goes wrong. So here's our situation. We're starting at point S, and we've got two choices to get to our goal. We can go through A, or we can go through B. The cost to get to either of those points, we call that G of n, is the same, 200. Now, the real remaining cost from A is 40, and from B is 50. But our algorithm here is a pessimist. It overestimates. Its guess, H of n, is 80 for path A and 70 for path B. Both are way higher than reality. So what does the algorithm do? It does some simple math to figure out the total estimated cost, which we call F of n. It's just the cost we already paid plus the guess for the road ahead. For path A, that's 200 plus its guess of 80, which gives us 280. For path B, it's 200 plus its guess of 70 for a total of 270. Easy enough, right? It looks at the two numbers, 280 and 270, sees that 270 looks cheaper, and it commits. It goes all in on path B. It follows that path all the way to the end. And just like our hasty shopper who thought he got a deal, it stops. It doesn't even think about looking back at path A. And when it gets to the goal via path B, it calculates the actual total cost, which turns out to be 250. It reports back, done. The best path costs 250. But is it really the best? Okay, let's hit the rewind button. We're going to run this whole thing again, but this time, we're going to use the logic of our careful, optimistic shopper. We're going to use an admissible heuristic. The setup is exactly the same, but check out our guesses now. They're much more optimistic. For path A, where the real cost is 40, we're guessing 30. And for path B, where the real cost is 50, we're guessing just 20. See? We're always underestimating, always optimistic. So let's crunch the numbers again. Path A's estimated total is 200 plus our guess of 30, so 230. Path B's is 200 plus our guess of 20, so 220. And, interestingly enough, just like before, path B still looks like the cheaper option to start with. So the algorithm makes the same first move. It starts exploring path B. So it heads down path B, and it discovers the true total cost is 250. But this is where everything changes. Because its initial guesses were so optimistic, it doesn't just call it a day. It hits the brakes, it stops, and reevaluates. This is the moment of truth. This is the golden rule in action. The algorithm compares the actual cost of the path it just found, 250, with the super optimistic estimate for the path it hasn't tried yet, path A, which is still sitting there at 230. And since 230 is less than 250, the algorithm thinks, wait a minute, there's a chance path A could actually be better. That low, optimistic guess is what keeps the door open. So it does exactly what our careful shopper did. It decides to go back and check the other option. It says, hold on, I need to go see what's really going on with path A, just in case. So it expands path A and discovers its true actual cost. And there it is. The real cost of going through path A is 240. It's better. By being optimistic, by underestimating, it was forced to keep its options open. And because of that, it found the truly best path that the overestimator completely missed. So after seeing all that play out, what's the big takeaway? What's the fundamental rule here that guarantees you find the perfect answer every single time? It really comes down to this. Overestimation is greedy. It's fast, yeah, but it's risky because it might jump on the first good enough answer it sees. Underestimation, on the other hand, is patient. It's thorough. It forces the algorithm to check out any path that could possibly be the best one. And that's what guarantees it will always find the true winner. And this guarantee, this promise of finding the best answer, is what makes A-star so incredibly useful. We rely on this optimistic searching every single day. It's what ensures your GPS gives you the actually fastest route, not just a pretty good one that might make you late. In a video game, it's how an enemy character finds the smartest way to get to you. It's even used to route data across the internet. In all these cases, getting the best answer isn't just a nice bonus, it's absolutely essential. So it kind of leaves you with the final thought, doesn't it? The whole logic of A-star is about not closing doors too early. It's a pretty cool reminder that sometimes being a little optimistic about what's possible, maybe even underestimating the difficulty ahead, is the exact strategy you need to make sure you find the very best path forward.